a ball moving back and forth along a path. This movement would eventually cease due to friction if it weren't kept going by the regular swinging motion of the system. This is known as forcing. The yellow loop is an attractor. It faithfully records the movement of the ball. The attractor isn't actually a trajectory. What it does is represent the regular motion of the ball. What could be simpler or more predictable? It looks as if nothing could upset such a nice, well-ordered system. But look what happens if we alter the pace of the forcing just ever so slightly. Astonishingly, the ball starts to move in a completely irregular and unpredictable way. The attractor goes wild. This is surprising behavior for such a simple system, and scientists have given it a name, chaos. But here, this word doesn't have its ordinary meaning. In fact, this chaos is pretty orderly. It plays by its own rules, and the attractor, seemingly so strange, begins to reveal both the details and the overall shape of its hidden structure. This pretty bundle of red thread is actually the trail left by a point moving along an unpredictable path, driven by the equation of a dynamic system within the contours of a strange attractor in phase space. This vocabulary may be incomprehensible to the layman, but it's everyday stuff to scientists trying to get to the bottom of just how chaos works and how it makes these patterns. To make it easier to understand, slices are taken through the attractor, and the traces left by the point each time it passes through the plane of the section are observed. If the trajectory were regular, only one point would be seen. But since it's chaotic, a whole array of points can be observed. Folds up in a ladder, stretches and folds again, which gives it this folded appearance, just like puff pastry. Two points that pass through a section very close to each other can be much further from each other when they pass through it again, shortly after. This shows sensitive dependence on initial conditions in chaotic systems. Each slice is called a Poincare section after its inventor, the early 20th century French mathematician, physicist and philosopher Henri Poincare, the brilliant forerunner of the chaos theory.